Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is combinations. We are going to see how the combinations is applied in probability. When we are selecting more than one items, we have to use combination formula to find the probability. Or else, if the numbers are lesser, we can easily use any one of the counting principle and find the solution. But in the case of more data, we have to use combinations so that the probability will be very easy for us. Now let us discuss what is combinations in detail with suitable examples. A simple definition for the combination is the number of ways selecting r items from a set of n. It is denoted by NCR. Do you see the formula? N factorial divided by n minus r factorial times r factorial. This is nothing but NPR, where this P denotes the permutation. We sometimes make a selection from a set without regard to order. Such a selection is called a combination. Okay, for example, if you play cards, for example, you know that in most situations, the order in which you hold cards is not at all important. Okay, let me take one example. Here is the example. We are supposed to find all the combinations of 3 letters taken from the set of 5 letters A, B, C, D, E. Okay, let me list out the combinations. So these are the combinations. Am I right? Totally there are 10. There are 10 combinations of the 5 letters taken 3 at a time. When we find all the combinations from a set of 5 objects taken 3 at a time, we are finding all the 3 element subsets. When a set is named, the order of the elements is not considered. Okay, thus A, C, B names the same set as A, B, C. Okay, let me say what is meant by subset first. A set A is a subset of B, denoted A is subset and or it coincides with B if every element of A is an element of B. I'll just type it on the board. Also, please note that the elements of a subset are not ordered at all. When we think of the combinations, we need not worry about the order here. Okay. So, what is meant by a combination? A combination containing k objects is a subset that containing k objects. Okay. Let us develop a formula for computing the number of combinations of n objects taken k at a time without actually listing the combinations or subsets. Okay, let me give you the combination notation. So this is how we denote the combinations. We call NCK or NCR. We want to derive a general formula for this NCR for any R is less than N. Okay, first it is true that when you find NCN, it is equal to 1. Am I right? Because a set with N objects has only one subset with N objects, the set itself. Then NC1 would be equal to N. Am I right? Because a set with N objects has N subsets with one element each. Finally, NC0, that is going to be equal to 1. NC0 is equal to 1 because a set with N objects has only one subset with 0 elements. Namely, it is just the empty set. Okay. To consider other possibilities, you can compare, look at the previous example, the first example we discussed. We compare the number of combinations with the number of permutations. Okay, I'll post a chart. From the previous example, these are the 10 possible combinations we got. I'm going to write this combination in permutation form. I mean each combination of 3 objects. So this is going to yield ABC, BCA, CAB. I have written everything in different combination. So same way, next one ABD can be written as ABD, BDA, DAB, DBA, BAD, ADB. Same way, all the 10 combinations can be different in 6 ways. So please note that each combination of 3 objects yields 6. 6 means, how can you rewrite 6 in factorial form? Yes, 3 factorial. So 5C3, because 5 and 3, we are writing 3 combinations from the 5 letters. 5-3C yields 3 factorial times 5C3 of these. Am I right? Okay. So this is the relationship between combination and permutation. In general, the number of combinations of n objects taken k at a time, nck, times the number of permutations of these objects, k factorial, must be equal to the number of permutations of n objects taken k at a time. Let me write that. Dividing both these sides by k factorial, you can also use r instead of k. So this can be written as 1 over k factorial times npk. npk, the permutation formula is n factorial over n minus k factorial, right? This is how we derive the formula for the combinations from permutation. Hope you are clear with this part? Okay. There is another kind of notation for nck, is binomial coefficient notation. The reason for such terminology will be seen later. First, let me give you the coefficient notation. Okay. This is the binomial coefficient notation. You should be able to use either notation and either form of the formula. No problem. Okay, let me take some examples. Here is an example. Let us find 7c4. NCR. We are going to apply the same formula and plug in the n value and r value. Please don't get confused even if I use r or k in this place. Both denote the same thing. So r. In the place of n we have 7, in the place of r we have 4. So let us just plug in. Replace all n's by 7 and all r's by 4. Then we will get, you can manually expand the factorial and solve the problem. In case if you're allowed to use calculator, you can use it. So that will save so much time. And here let me show you how to do it manually. 7 factorial means you have to multiply the number starting from 1 to 7. Okay, 1 times 2 times 3 times 4 times like that. 7 minus 4 is 3 factorial in the denominator. I have just expanded all the factorials. This is for 3 factorial and this is for 4 factorial. In the top I have 7 factorial. Now cancel out all the common factors and simplify as much as possible. This will get cancelled out. Am I right? This entire thing. And 3 times 2 is 6. So even this will get cancelled out. And we will be left over with 7 times 5, which is equal to 35. Hope you are clear with this example. This is how we work out combination. Okay. Let me show you one word problem. Okay. Please have a glance over this example question. At Grand Senior High School, there are 15 names on the ballot for junior class officers. 5 will be selected to form a class committee. Okay, we have 3 parts of question. Let us start with part A. How many different committees can be formed? Okay, the order of the names chosen for the committee is not important. So, this situation is a combination of 15 names chosen 5 at a time. Am I right? 5 will be selected from the 15 names. Okay, so NCR. Here we are going to find 15C5 for part A. So similar to the previous example, we are just going to apply the formula. Replace en by 15 and r by 5. So we will get same thing. We are going to expand the factorial and cancel out the common factors. Hope you are clear with this step. Okay, just expand and cancel out the common factor and give the final answer. I'm getting 3003. Hope you can try this part. Work out the calculation part and check whether you're getting 3003 or not. Hope you're clear with part A? Okay, let us now see what is part B. Part B question is asking us to find in how many ways can the committee be formed if each student has a different responsibility. So in this situation, order is important, right? Because each person chosen is assigned a specific responsibility. So this situation is a permutation of 15 names chosen at a time. If the order matters, you have to apply permutation. If order does not matter, you have to use combination. That's the reason I have given you this example. You should know the difference between permutation and combination. Okay. So hope you understand when to apply the permutation. So whenever order is important, you have to use permutation. Whenever in the questions, if the order does not matter, then you can use the combination. Okay. Now I'll give you the permutation formula. Permutation is very similar to the combination. Okay. Here you have to identify what is n and r here. In the question, n is 15 and r is 5. So we will get. Hope you can expand the factorial portion. Okay, and cancel out the common factors and multiply the leftover numbers. For this problem, for this part, I'm getting 360, 360. Please check whether you're getting the same answer or not. I'm not showing the factorial part because factorial is very easy, expanding the factorial. Hope you can do that part. Okay, let us now concentrate part 3. In the last part of the question is asking us to find if there are 8 girls and 7 boys on the ballot, what is the probability that a committee of 2 boys and 3 girls is formed? Okay. So this question is asking us to find the probability that a committee of 2 boys and 3 girls is formed. Okay, find the number of ways to select 2 boys and 3 girls and divide the total by the possible number of 5-member committees that can be chosen from 15 students. So here we are going to use combination. Since the order of the girls and boys chosen is not important, no? So we are going to use combination. So we need to find the probability of 2 boys and 3 girls. 2 out of 7 boys and 3 out of 8 girls. Total 5-member committees out of 15. So it can be written as, we are supposed to find the probability of 2 boys and 3 girls. So 2 out of 7 boys and 3 out of 8 girls divided by total 5-member committees of the 15. So 7C2, 8C3 divided by 15C5. We are just applying the combination for all the 3. Apply the combinations formula and expand the factorial, cancel out the common factor for each of the 3 combinations. And you should get, finally I'm getting 56 over 143 as my answer. Hope you get the same answer. You can also give your answer in decimals or percentages for probability. There are many examples. Hope you got an idea on combinations now. Hope you understand the difference between combination and permutation. In case if you get any query regarding this topic, kindly let me know. See you.